Hi everyone, welcome to this video. So in this particular session, I want to discuss with you this interesting question from physics. So this question is on a topic called waves. So let's just read and answer the question together. So the question reads, the following diagram shows the propagation of a water wave. So this is our diagram. This is a displacement time graph. So we have displacement on the y-axis and time on the x-axis. Okay. So the first question says, what type of a wave is a water wave? So you can always try to pause the video, try the questions on your own, then unpause the video to see what I've suggested. Okay. Then the other question says, from the diagram, state the period of the wave, the amplitude of the wave. Then part C says, calculate the frequency of the wave, the speed of the wave if the wavelength is 6 meters. Okay. So the questions might look a little bit difficult, but they are very, very easy. So let's just break them down together. Okay. So the first question says, what type of a wave is a water wave? So I want to introduce you first of all to two types of waves. So based on how the particles vibrate, we have two types of waves. Okay. Okay, so we have two types of waves. Number one, we have something called longitudinal wave. Number two, we have something called transverse. Okay, so we have transverse waves and longitudinal waves. Before we even just explain what a longitudinal wave is and what a transverse wave is, you first of all just want to understand what a wave is. What is a wave? Okay, so a wave is simply a disturbance that travels through the medium, okay, and transfers energy from one point to another without causing the permanent displacement of the particles of the medium. So the particles will begin to vibrate. So think of these as particles, okay? Then there's a wave. So a wave will pass through the particles of the medium. It will cause these particles to vibrate. Based on the type of the wave we're talking about, they can either vibrate up and down, perpendicular, or they can vibrate back and forth, forward and backwards. Okay, yeah. So based on the type of the wave. So basically, a wave is simply a disturbance that travels through the medium and transfers energy from one point to another without causing the permanent displacement of the medium itself. The medium does not move. Only the particles of the medium will begin to do what? To vibrate. And it's those vibrations that help the wave do what? Transfer energy from one point to another. Now, based on how the particles vibrate, some particles will vibrate up and down. Okay? Let's say the wave is moving like that. There will be this particle. There will be this particle that will be dancing up and down. It will be vibrating up and down, perpendicular to the direction of the wave travel. Okay? So the wave is moving in that direction. Then this particle is vibrating perpendicular to the direction of the wave. So this type of a wave where the particles of the medium vibrate perpendicular to the direction of the wave, we call it a transverse wave. Okay? So what do we have here? Transverse. A transverse wave is a type of a wave where the particles of the medium vibrate perpendicular or at right angles to the direction of the wave. That is what we call a transverse wave. Examples of transverse waves include water wave. Water wave is a transverse wave. What else? Electromagnetic waves. Okay? Electromagnetic waves. All those electromagnetic waves, the radio waves, the microwaves, the ultraviolet, visible light, all those are what? Good examples of transverse waves. Okay? Yeah. Then we also have another type now where, let's suppose the wave is moving in that direction. Okay? So the wave is moving in that direction. But this time around, we have this particle here. This particle here is not vibrating up and down. No, it's vibrating back and forth. Okay, it's vibrating back and forth. It's vibrating forward and backwards, parallel to the direction of the wave. So you can see that here, the particle is now moving in the same direction, is vibrating in the same direction as the wave travel. Okay, so a type of a wave where the particles of the medium vibrate parallel to the direction of the wave, we call it a longitudinal wave. Longitudinal wave. Okay, so a longitudinal wave, the particles vibrate what? Parallel. Okay, transverse wave, the particles vibrate how? Perpendicular. Like that. Okay, good examples. What are some of the examples of longitudinal waves? Examples of longitudinal waves include, a good example is sound wave. Okay, sound wave. Okay, in the comment section, try to give me another example of what? A longitudinal wave. Okay, yeah, we have so many examples. Okay, so I hope you understand the difference between a longitudinal wave and a transverse wave. Transverse wave, particles vibrate perpendicular. Uh, Longitudinal waves, particles vibrate what? Parallel to the direction of the wave. But I also try to create other videos where I will explain about the properties of longitudinal waves, transverse waves. I'll talk about things like the troughs, the crests, the rarefactions, and things like that, the compressions. Yeah. Yeah, so I hope you understand the difference between transverse waves and longitudinal waves and the wave itself. Okay, let's now go back here. So what type of a wave is a water wave? So we know that a water wave is what? A transverse wave. Transverse. Okay, so that is the answer. Water wave is a transverse wave. The other question says, from the diagram, state the period of the wave. Okay, so when we try to discuss waves, we have terms that are associated with waves. We hear things like period, the frequency, the amplitude, the wavelength, okay, and things like that. Particles that are in phase, wavefront. Okay, yeah. So we'll try to explain these as we discuss these questions together. Yeah. So from the diagram, state the period of the wave. So by period of the wave is simply the time taken to make one complete vibration. Okay? One complete vibration. That time it takes to make one complete wave, one complete vibration is what we call a period of the wave. Now, a complete vibration from the diagram starts from there, okay? And it moves. This is a half vibration, half wave, and it completes its cycle like that. Okay, so when it repeats itself, when it wants to begin another cycle, a full cycle, that is a complete vibration. So you can see that from the diagram, it takes 4 seconds to make that complete vibration. We call that time the period. Okay, so the period of the wave is simply the time it takes the wave to make one complete cycle, one complete vibration. So from this diagram, you can see that the period is 4 seconds. Okay, so 4 seconds. So state the period. So the period here, period, we use capital letter T for period. The answer is 4 seconds. Okay, the other one says state the amplitude. Now, the amplitude of the wave is simply the maximum displacement a particle moves. Okay, the maximum displacement a particle covers from its rest position. So we assume the rest position is here. The maximum displacement, so you know that the particles are vibrating. Now that maximum, the peak height, the maximum displacement a particle covers from its rest position is what we call the amplitude. So this distance here, this displacement is what we are calling the amplitude. So that is the amplitude. Okay? Amplitude. So this one here, it should be, it's a positive value. This value and that value are the same, okay? Just that this is negative, but when you're stating the amplitude, it should be positive. Yeah, so this is 5, this is also 5, that is 5, that is also 5. So amplitude in this case is what? You can even see displacement is in meters here. You look at the units here. So the amplitude is 5 meters. The maximum displacement a particle moves from its rest position is what we call the amplitude of the wave. Okay, so the answer here is what? 5 meters. Okay, The other question says calculate the frequency of the wave. Frequency of the wave. So I want to let you know about the relationship between period and frequency. Okay? So period and frequency are inversely related to each other. So this is how you calculate the frequency. So frequency is basically equal to 1 over period. Okay? So frequency is equal to 1 over period. If you have the frequency, to find the period, it's the same thing. You say period is also equal to 1 over frequency. They are inversely related to each other. Yeah. So this is how we find the frequency. Frequency is basically equal to 1 over period. So this is part C now. So C1. So find the what? The frequency. So frequency is equal to 1 over period. So frequency is equal to, we know that our period is equal to 4 seconds. So frequency will be equal to 1 over 4 seconds. So frequency is equal to 1 over 4 is the same as 0.25. Okay, you can use your calculator. In physics, we allow calculators. So 0.25. Now, what are the units for frequency? Okay, so the units for frequency are the hertz, capital letter H, and a small letter what? Z, like that. So that is how you find the what? The frequency. So this is the answer. Okay, the other question says, find the speed of the wave if the wavelength is 6 meters. So in future videos, I'll also explain how you can state the wavelength from the diagram. So here we want to find the speed of the wave given the wavelength. So I want to also introduce you people to something called the wave equation, okay? So the wave equation is an equation that tries to relate velocity of the wave, the wavelength of the wave, and the frequency. So this is how we write it. So speed of the wave, V, is equal to frequency multiplied by the wavelength. So we use the symbol lambda for wavelength. So this is the wave equation. It means velocity of the wave is basically equal to the frequency of the wave multiplied by what? The wavelength. Yeah. So they've given us that the wavelength here is 6 meters. Okay. So let's just correct our data. We know that our wavelength is 6 meters. Okay. Then what else do we have? We have the frequency. We calculated from part C1. So our frequency is 0.25 hertz, like that. Okay. Then what do we do? So we're going to use this equation to find the velocity. So we shall say velocity is equal to the frequency. So the frequency is 0.25 multiplied by what? Multiplied by the wavelength. The wavelength is 6 meters. So we're going to multiply 0.25 by 6. So this is the same as 1 over 4 times 6. So 2 there, 2, 2 there, 3, 2 there, 1, 2 there, 1.5. Okay, so when you multiply 0. You can use your calculator, like I said, 0.25 by 6, I'm getting 1.5. So my velocity is 1.5 meters per second. This is speed, okay? So this is the speed of the wave in this particular what? Question. And that is how you basically answer this question. Okay. So I hope you found this video helpful, and if you did, you want to share the video, you want to leave a comment, and you want to like us. Okay. Bye-bye.